Dear listener, my name is Elisabeth Delbeke, and it's my pleasure to give this keynote presentation focusing on the synthesis of Quaternary ammonium sophorolipids as renewable-based antimicrobial products. As the title already implies, this project is based on the modification of renewable resources, in particular sophorolipids. Nowadays, renewable resources gain great interest as alternatives for fossil resources. This is because of the limited availability of fossil resources and their negative impact on the environment. Until now, only a slow transition towards a bio-based economy took place, and in Europe, only 8% of the chemicals are produced out of renewable resources. The conversion of these renewable resources mostly follows the same general approach. In the first step, the renewable resources are broken down into so-called base chemicals. In the second step, these building blocks are used for the synthesis of more complex products such as pharmaceuticals, cosmetics, detergents, polymers, etc. For high added value products with complex structures, this approach often requires a long reaction sequence with multiple reaction steps and is therefore economically not feasible. As an alternative to this approach, renewable resources with a complex structure could directly be used for the synthesis of complex products. This would increase the sustainability of both the process and the end product. This new approach is the basis for this project, where sophorolipids are used as renewable resources with a complex structure. Sophorolipids are surface-active compounds or surfactants since they contain a hydrophilic and a hydrophobic part. They belong to the class of biosurfactants since they are produced by microorganisms. Surfactants can arrange at the interface of surfaces, thereby reducing the interfacial tension, or they can assemble into different types of nanostructures, for example micelles. Therefore, they can be used as detergents, emulsifiers, etc. Sophorolipids have already been commercialized by the company Ecover as a detergent in their hard surface cleaning products. Sophorolipids are produced by the yeast Starmerella bombicola through fermentation. The yeast feeds on oil or fatty acids as hydrophobic carbon source and on glucose, a sugar, as hydrophilic carbon source, and it starts with the production of the sophorolipids in its stationary phase. Sophorolipids are thus secondary metabolites, most probably used by the yeast as extracellular carbon storage and as defense agent against other competing microorganisms. Here we can see the microbial pathway of the sophorolipid production. Synthesis starts with the hydroxylation of the fatty acids, followed by two subsequent additions of a glucose unit. This glycolipid is then acetylated at 1, 2, or none of the 6 positions on the sugar groups, and finally the products can be esterified to the lactonic compounds. This microbial pathway thus gives rise to a variety of end products, with the diacetylated sophorolipid lactone being the major compound. Sophorolipids have as advantages that they display a low ecotoxicity combined with high biodegradability. As mentioned before, they are produced from renewable resources. They possess surface-active properties which are linked to interesting biological activities such as anti-cancer and antimicrobial activity. They are produced by a non-pathogenic yeast with a high production of 400 grams per liter. As a disadvantage, their price is not competitive with the price for chemical surfactants. Also, their natural production is restricted to only a few derivatives, making their application range limited to the detergent sector. This leads us to the goal of this project. As mentioned before, sophorolipids combine interesting surface active properties with biological activities. The drawbacks are that their price is not competitive with the price for synthetic surfactants and that the variety in their structure is limited by the microbial production. This makes it difficult to play a role of interest in the detergent market and makes it necessary to look for other applications. Through chemical modification, the sophorolipids can be transformed into high added value compounds with applications in the medical and cosmetic sector, for example in targeted drug delivery. We envision to transform the microbially produced sophrolipid lactone in a first step to an aldehyde intermediate. This intermediate would then be transformed into quaternary ammonium salts. These derivatives contain a nitrogen atom, a characteristic which is not feasible through microbial production, and they have a positive charge. The first target in the synthetic pathway was the aldehyde intermediate. The most straightforward way would be to form this aldehyde through an ozonolysis reaction, followed by the cleavage of the 9-oxononanoic acid metal ester group and the acetyl groups through a transesterification reaction. Unfortunately, this reaction pathway did not lead to the desired sophrolipid aldehyde. The intermediate dialdehyde was obtained after ozonolysis, but transesterification to the sophrolipid aldehyde failed. Analysis of the reaction mixture demonstrated the presence of the aldol condensation product of 9-oxononanoic acid metal ester, indicating the non-compatibility of the aldehyde function with alkaline conditions. A different reaction pathway was set up to circumvent this problem. According to literature procedures, the sophrolipid lactone was transesterified with sodium methoxide towards the sophrolipid metal ester. Ozonolysis of this metal ester derivative was also envisioned, but did not lead to the desired sophrolipid aldehyde. Acetylation of the sugar head proved necessary to obtain the sophrolipid aldehyde after ozonolysis. In this way, we were able to synthesize the desired aldehyde. At first, workup of the ozonolysis reaction was performed with dimethyl sulfide. In this case, the 9-oxononanoic acid metal ester side product could not be detected. Instead, analysis indicated the presence of a stable ozonide intermediate. Since we were striving to develop a green synthetic pathway, we considered it interesting to be able to also isolate this 9-oxononanoic acid metal ester as a valuable side product. Therefore, the reaction conditions for the ozonolysis reaction were changed and sodium triacetoxyborohydride was used as a reducing agent. This new procedure indeed prevented the formation of the stable ozonides, enabling the isolation of both the desired sophrolipid aldehyde and the 9-oxononanoic metal ester. These compounds were separated by automated flash chromatography. This purification step proved to be a bottleneck as well, since the mixture always contains some trace amounts of other microbial products, mostly the saturated sophrolipid compound, which can't be transformed during the ozonolysis reaction. With the aldehyde intermediate in hand, a synthetic pathway for the quaternary ammonium salts was worked out. In a first step, the sophrolipid aldehyde was transformed to a set of sophrolipid tertiary amines by reductive amination with several secondary amines. The derivatives contain a combination of methyl, butyl, benzyl, and octadecyl groups on the nitrogen atom. The sophrolipid amines were purified via automated flash chromatography. The sophrolipid amines were then transformed into the desired sophrolipid quaternary ammonium salts through a quaternization reaction with an alkyl iodide. all derivatives were obtained in almost quantitative yields. Finally, the sugar head is deprotected through a transesterification reaction. Also here, almost quantitative yields were accomplished for all derivatives. Next to the synthetic work, an evaluation of the antimicrobial activity was carried out. The compounds were tested against 2 gram-positive strains, namely Staphylococcus aureus and Bacillus subtilis, and against 2 gram-negative strains, namely Escherichia coli and Klebsiella pneumoniae. A significant growth inhibition was observed for some of the tested compounds against both the gram-positive strains, but not against the gram-negative strains. For the active compounds, minimum inhibitory concentrations were determined against 4 gram-positive strains, namely Staphylococcus aureus, Bacillus subtilis, Enterococcus faecium, and Streptococcus pneumoniae. The antibiotic gentamicin sulfate was used as a control. The best results were obtained with the Quaternary ammonium salts containing an octadecyl chain on the nitrogen atom. Both the acetylated and non-acetylated derivatives actually performed better than the antibiotic gentamicin sulfate when compared on a molecular basis. Results for the other active compounds are not displayed. To conclude, we can state that a variety of sophrolipid derivatives was synthesized. The best antimicrobial activities were obtained with Quaternary ammonium sophrolipids containing an octadecyl chain on the nitrogen atom. These results give good prospects for the applications of these products in the medical sector. I would like to thank you for your kind attention.